Okay, so this is going to be the start of my foray into overscanning, and I want to start this by demonstrating how to calculate the shot resolution from the focal length. Okay, so you can see that I've already got a plate in the loaded into Nuke, and you can see that it's got a little bit of camera motion on it. You can see that at the first frame it starts sort of looking up here, looking up towards the lower edge of these bedrooms. And then it's a very short shot, it's only a couple of seconds long. Over a course of 50 frames the camera sort of pans down and fixes on the hero character here holding the blanket. So this is a scenario which I'm going to partially complete, but our goal here is to take a frame of this shot into Photoshop for painting over. But I want to make sure that I've got enough overscan for the whole of the shot. So not just the overscan to cover this frame, but I've also got sufficient information for other parts of the frame. Okay. So I'm going to start by making a copy of my plate. I'm just popping it over here. And then I'm just going to connect my viewer to this. And the reason why I've done that is because I'm going to use a checkerboard for marking out my matte painting. Just as a reference for my matte painting, but I'm going to want to see that from behind the plate. What I want to do is I want to reveal this area to the matte painting. So what I'm going to do is I'm going to type O to bring out a roto node, and again, if you've seen any of my earlier demonstrations, you'll see me doing this. So I'm just going to create a spline, which is certainly not going to be the most accurate thing in the world, but will be sufficient for our purposes. And then I'm just coming down here and I'm just going to sort of roughly, again, it's not necessary to be this precise, but for the sake of the demonstration, but old habits die hard, etc. And then just pull that out of the way here. Okay, so we've got our alpha channel there. Okay, in order for that to read through, I need to invert the alpha, so that's inverting the red, green, blue and alpha. I just want to tell that to invert just the alpha, and then I just want to cookie cut that out by adding a pre-mult node, and that will chop it out, and that will allow me to reveal back the checkerboard that's going to be in this kind of space. Okay, so now I'm going to basically set up a projection just by copying these nodes. So I'll copy that. I don't need the projection camera, I'll create my own for that. So these nodes I'm going to need, and on top of that I'm going to need a scanline renderer. I've just noticed that there isn't one within the project. So scanline renderer is at the base of the node graph. It's going to be populated on this side from a card node, and the card node is going to receive a texture via a Project 3D shader. The scanline renderer needs the shot camera, and then I'm just going to introduce a checkerboard. Okay, this can be any old checkerboard. I'm only using one of them, so I don't need my multi-tool. Another advantage of just pulling one straight out of there is I know it's going to inherit the resolution of the project. If I just quickly flip over to my project settings, you can see my default project setting here is 1280 by 720, and that matches the plate, which is 1280 by 720. Those are important things to bear in mind for what we're doing, because we are actually working with resolution in this particular demonstration. So at this point we would be going back to our plate and we'd be looking for the optimum frame from which to generate our projection camera and generate our still image for painting over. I'm focusing on this back end of the shot just purely and simply because, let's say for the scenario that I was wanting to extend this house. So I was wanting to extend this house, and I wanted the best possible coverage of that particular element. Now, whether I chose 50 or 48 or 49 is arbitrary. What I'd be looking for is maybe the frame with the least motion blur. But for the sake of this, I'm going to say frame 50 is the frame that I want to export out. So this is the frame that I'm going to want to project onto. I'm going to want to be projecting from. Okay, so for projection purposes, and again we've done this before, so if you've seen previous demonstrations you'll know exactly what I'm doing. I'm on frame 50, I want to make a duplicate, or should I say a copy, of my shot camera, and I always go through the same process with a shot camera. I'll identify it, I'll rename it, so I'll call it projection camera. I always append it with the frame name from which I've generated it from. I've generated it from frame 50, so all these values in the parameter boxes there relate to frame 50. I don't want them to change. Currently they're animated, you can see those values changing. I don't want them to change, so I'm going to kill the animation by saying no animation on all knobs. That gets rid of all the keyframes, but what it does do is it retains all the values that were available at frame 50, so it's locked onto frame 50. Finally, give it a colour. I tend to use blue to differentiate projection cameras from shot cameras, but again that's a completely personal choice and is arbitrary, isn't important for the completion of this project. Okay, so that's me pretty much set up in terms of the projection. If I just flip over into 3D here, in fact I'll stay in 2D for a second and just show this. We can see the effect of the shot camera on that projection. So the projection of the checkerboard texture onto the card is fixed, but the shot camera is moving up, hence the reason why it's creating that little animation. If we look at it in 3D, we can see it a little bit more clearly. So we can see the shot camera, we can see the projection camera, and we can see the card. So you can see there that on frame 50 the two cameras are over the top of each other, we can't see the difference between them, but as I start to pull that back you can see the separation. You can see the shot camera just tilting up a little bit relative to the projection camera, so we can see the difference between the two. Okay, now one of the reasons why I wanted to just lock onto this frame and just focus on it is to look at the focal length. So on frame 50, which is where I was, if I open up the shot camera and the projection camera, if I flip over into the projection tab, you'll see that all the projection attributes all have exactly the same values. So at frame 50 we'd completely expect that, and to be honest on any other frame I wouldn't expect there to be any changes. It's unusual. Occasionally you'll get an animation of a focal length or something just to kind of create a zoom effect, but these are unchanging. Okay, so let's just take a look at what these do. So this is my projection camera, this is what's projecting this texture onto this card. So if we take a look at the focal length here, I'm just going to put my cursor into the number, and then I'm just going to start to tab it down, and you can see that what's happening here is that the projection camera, and we can see this from the highlighted frustum there, which is in green, we can see that as I dial this number down, you can see that what it's doing is it's flattening out, it's widening and shortening the focal length, and as a consequence of that it's having a magnifying effect or an overscan effect on the texture being projected. If we go the other way beyond 62, which was the default, we're now lengthening and narrowing the focal length, so we're actually demagnifying in that particular example. So I'll just set it back to 62. So when we go down in numbers below the optimum, we're actually widening it out and we're creating overscan. That's important because that's what we need to do in this particular case. Okay, I think this is probably a good time to actually bring the two images together. So I'm just going to quickly flip back into 2D. I'm going to select my Primo node and type M to add a merge node. I did it that way so that it would merge the plate in on the A side of the composite, which is what I want because I want the rotode plate to be sat over the top of the checkerboard. The checkerboard is the matte painting that would exist in the background, so I want to see it as such in the background. Okay, so we can see this is where the matte painting would go, this is where we would be painting the house and extending the house. Okay, so if we just scrub through this, we can see the issues around coverage. So we can see maybe we're getting a little bit of slither of coverage that's where it doesn't quite reach the end, and we're seeing a bigger area up here, which is where it's running out of coverage, and this is where we would need to create overscan to compensate for this. So what we would do is that we would get our projection camera, and now we would start to bring our focal length down, so we're effectively widening the focal length, and I'm bringing that down until we got to the point. So around about that point there at 48, we're at the point now where we've actually got sufficient overscan to fill the shot. But I'm actually just going to go down a little bit more than that, let's say to 42, so I've created some additional overscan, maybe a square or two on this checkerboard. And the reason why I would do that is because sometimes when we receive these projects commercially, we receive them before the final edit's been done, and the editor, even though the editor's given you these frames in good faith, believing these to be the frames that he's going to use in the edit, sometimes slight changes are made, and he may just want to slide the edit a couple of frames in either direction, and as a consequence of that, it might create extra space that we hadn't made provision for. So just by giving ourselves a little bit of extra overscan there, it's kind of like a commercially savvy thing to do. It certainly isn't harming the production, it's giving us a little bit of extra space. We can always address it when we come to the calculation, which we're going to do now. So to do this, I'm just going to create a little bit of space here, and I'm going to add a backdrop node. And on the backdrop node, I'm just going to extend it out a little bit, and I'm going to set the font to be something a little bit bigger than what it currently is. That may be a little bit too big, so I'll just bring that down to 20. We need to be able to see it, but we don't want it. We don't want our information to be running out of the side. So why have I done this? I've done this because I want to type in the calculations as I go along. Hopefully that will, for demonstration purposes, that will make it a little bit easier to understand, and also it will give us a source of reference. Okay, so I'm going to start. So I'm going to capitalize these. So I'm going to have my original focal length, which I know is 62, and then my new underscore focal length, which I know is 42. Okay, so the first calculation is a division between the original focal length and the new focal length, and that gives us the difference between the two. So I'm going to type original underscore focal length divided by new focal length equals. Now we have to calculate it. So I'm just going to bring up my calculator in Windows here. So this is a straightforward division, 62 divided by 42, and it's going to give me this value, which is quite lengthy, 1.4 something, and I'm going to copy that to the clipboard. Okay, that is going to go into there. So that is the difference between the original and the new focal length. For calculating a resolution from a focal length, this is an absolutely pivotal value. So I'm going to carry on with this now. So the next thing we need to know is we need to know the original resolution, and we know that to be 1280 by 720. We can see that up here, and we could also see that in the project settings before. And then pivotally we want the new resolution, and this is what we don't yet know, and this is what we've got to calculate. So this is where we bring this back. So our value is already in there, so what we want to do is we need to multiply this by the original resolution. We need to do this both on the width and on the height. So I'm going to choose that value, and I'm going to multiply that by the width, which is 1280, and say OK, and that's giving me a value of 1889.52, etc. Now, one thing I need to say about resolution is that it will not take a percentage point like this. It has to be rounded up. So in this case, it's going to be 1890. So I'm going to have to put in there 1890 multiplied by, and then I have to do it again. So again, I just have to come to this original value here, select it, and then multiply that by the height, which is 720, say OK to that. And again, this is the same. I need to round this up in this particular case to 1063. So 1063. And that is the end of the calculations. It's surprisingly easy. What that's done is that's told us that from a focal length of 42, this is our new resolution, 1890 by 1063. So what would we do now? We would do now is that we would add a right node, and we would write out our frame 50. So we'd come to frame 50, and we would write this out as and then take that into Photoshop. So that's exactly what I'm going to do. I'm going to come and I'm going to add it. I'll just put it in my desktop, and I will call it Matte Painting Projection 50.exr. Because I'm using the EXR format and I've typed that suffix in to the right node, then it automatically populates the parameters within the right node for what I need. The only thing I really need to do is I just need to make sure that I'm rendering from the correct frame, which in this case is frame 50. So I'll say OK to that, and that has rendered out my frame from frame 50 of the plate. Okay, so the next thing I need to do is jump over into Photoshop. So here I am in Photoshop, and I'm just going to open that particular file. So it's on my desktop, and it's MP Projection 50 there. So here it comes, and this is my file. So we can see that this file is identical to the one that we saw in Nuke. If we come into the image size, we can see that that's 1280 by 720, and it's this that we need to change. So I actually need to change the canvas size here. I don't want to actually enlarge this image, I just want to change the space that's available, which is what we would use for painting over using the overscan. So I want to change this value to 1890, and then the height to 1063. These were the values that we established, and I can say OK. And what that's done is that's extended the canvas to basically meet our new resolution. All this area that we see now as a checkerboard is overscan, and this is where we can perform all our matte painting. So you can see how easy it is now just to extend on this and be absolutely ruthless in terms of our precision on how we basically add this to the composite image. Okay, I'm not going to do that because obviously that's not the purpose of this demonstration. So what I'm going to do is I'm just going to save this back out. So I'm going to save it as, and I'll save it with the same name, but I'll just append it with new res and then save it. And then I can shut that down and close down Photoshop. So now we can bring this back into Nuke and test it against the original. So I'm going to bring in a read node, and again go to my desktop, and then come down until I see my MP, and there's the one there with new res, and open that. Now I should now be able just to swap it out with my original checkerboard. And what I should see now on frame 50 is I should see that that image is identical to the image that I rendered out over here. So the easiest way to check that is just to toggle the merge on and off. So the merge is merging the plate over the matte painting. So by turning that off, I'm actually hiding the plate and then showing the plate. And we know the plate is over the top of this image. So we can see there that they are identical. Well, strictly speaking, they're not. If you're eagle-eyed, you may just have seen that slight deviation there when I turned the two layers on and off. It shows that you're breathing if you did, and essentially what that is, I can imagine people that are new to this actually sort of seeing that and thinking they've done something wrong, and you haven't done anything wrong. What this is a consequence of the rounding up, because because we were working with partial integers when we actually set the new resolution and we had to round them up to whole integers, what we've got here is a slight deviation between the two. Even though it's actually less than a pixel, it is noticeable. Okay. One of the other things that you might typically see in this kind of scenario, in terms of difference between one image and the other, is arising from things like motion blur. Because one of these images is a moving image with motion blur, and another one of these is a still image where we may well have sharpened it and done various other things, and the consequence of that is that there's a disparity between the two. Now that's not to say that we can't fix that. The scanline renderer, for example, has multi-sample in it, has all sorts of shutter controls inside here that we can use to replicate the motion blur from a live shot like this side, and then apply that to anything that's coming in via the scanline renderer, which in this case would be the matte painting. So we can certainly adjust that, but that's way beyond what I want to cover today. So that's pretty much it. We've proved the concept. We've been able to successfully take our image from Nuke into Photoshop. We've been able to apply our calculation to that image in Photoshop to generate the overscan. We've then been able to output that and bring that back into Nuke and test it against our original plate, and we were able, fortunately they matched up. So I'm going to wrap up at this particular point. What I would say is that personally I found the learning necessary to record this demonstration quite challenging, but really rewarding. And I have to say that I'm increasingly surprised by how little of this information is around in the public domain. More importantly, I hope that you found it useful and that you'll be able to apply this to your own projects.